have amongst us as the panelist of the session, Dr. Ramesh Daryapukar, who is the Chief Executive Officer, Lars Enviro Private Limited. Very warm welcome to you, sir. May I also invite Mr. Kishan Karunakaran, who is the CEO, Bio India Private Limited. Very warm welcome to you, sir. We also invite onto the stage Mr. S.R. Kumar, Founder Director, Aruna Green Ventures Private Limited. Very warm welcome to you. It's my privilege in inviting Mr. Devanand, Managing Director, Cancure Birds Private Limited. Very warm welcome to you, sir. We're also inviting, may I have the housekeeping staff onto the stage, please? We will manage the stage in a few seconds now. We also would like to invite Mr. Karthik Prabhakar, who is the Head of Operations Inclusive Energy India. We're just taking care of the stage in a few seconds. May I have the housekeeping staff? Organizing team can quickly call the housekeeping staff to kindly join us onto the stage and help us with the needful. Ladies and gentlemen, it has been a very wonderful and fruitful day 3. We have had some very interesting and interactive sessions. We are hoping for yet another, though we have a bit of a mishap, but then we would take care of it. And like they say, the show must go on. We will go on.
Yeah. In fact, hi, good afternoon. I was just going to ask if all of you are still awake, and I got the answer beforehand.
That's a good check, sir. Thank you. Over to you, sir. We'll take care of this.
Hi. Good afternoon. I mean, after lunch session is always difficult, but I'm happy to see that the fraternity is still here, just because that we have got the hunger for the knowledge, hunger for biogas, and want to make biogas happen. And it will never happen unless until we come together. When you talk about the value chain, everyone has got the role to play. Whether you talk from the supply chain perspective, we always talk about the technical thing, financial thing, and the social thing. So it's very, very important that we model out everything properly. Otherwise, it doesn't work. It has to be a win-win situation for all the stakeholders. And we need to do our work properly in a very coordinated manner. That's the need of the hour. Then only we can really push the sector, and then we can see the pull from the market perspective. Fortunately, as you heard in morning, a lot of push is being given, or at least intention is there. I think it can't be enough, because biogas has got so many different dimensions. You can talk from the waste management perspective, you can talk from the gas perspective, fertilizer perspective, you can talk from the, Swachh Bharat Clean India mission perspective, Atmanirbhar Bharat perspective, women empowerment perspective, energy independency perspective. There are n number of things, in fact, we can keep talking about. The objective function should be clear, and we are married to biogas. That's why we are here once again. And that makes sense to me, because, till the date we are there, humans are there, organic waste will be created. So this is something which really needs a proper push in a very holistic manner. I think we can get it cleaned. Should we stand up or something and let it play? Yeah. Okay. So, should we start? At the back, can you hear me? Should we start? Okay, sounds good. Yeah. So we are still awake for sure, and thanks to Kumarji. Yeah. So he got extra power, right? I think all of us. So I will start very straightforwardly, and I think we have got a very eminent panel over here. Maybe I can just quickly introduce them. Many of them, they don't need any introduction, but it's very important that all of us are on the same page, the people on the desk as well. So maybe I take the honor to start from my right. Dr. Ramesh Daryapukar. He's the CEO of Lars Enviro Private Limited. He specializes in biogas technology and waste to energy. He has over 36 years of professional experience supervising over 500 projects in environmental engineering from concept to commissioning in India and abroad, which is very important when you talk about any such kind of projects. It has to be end-to-end Yeah, and when you talk about the project timing as well, so it has to be end to end, from concept till realization. He's one of the very few experts in Southeast Asia having the distinction of handling 350 plus bioenergy reactors. He is distinguished by many awards and recognitions and has a keen interest in research and academics. He's heading Last Enviro Private Limited as CEO since its inception. So we have got the honor to have you over here. And in fact, he also got an award from REI side, REI award. Kishan, CEO Bio India Private Limited. So he's a graduate from NUS Business School, Singapore, and has over 14 years of experience in the biofuel and waste to fuel sector in India, Southeast Asia, and Middle East. Set up Tamil Nadu's first commercial scale biodiesel manufacturing unit and one of India's earliest commercial scale biodiesel manufacturing unit in 2008. Sold more than 40,000 million ton, I need to repeat this, sold more than 40,000 million ton of biofuels and waste as an individual entrepreneur before starting up Biofuel. More than 20 years of experience in B2B sales and transactions. So, welcome. So, I will start from my left with Mr. Kumar. He is the founder director of Aruna Green Ventures Private Limited. He's one of the recipient of REI award as well. So congratulations to you as well. He's a mechanical engineer from the University of Bangalore, having worked in Canada and other nations. He has 20 years of international experience and has traveled to over 40 countries for business assignments and seminars, and has developed he develops and manufactures a variety of new green products. I think he will be talking about few of the things, including compact and contemporary biogas plants, bio-toilets, organic waste converters, shredders, among others. Mr. Dev Anand here, MD Kankyo Bert Private Limited. He's a mechanical engineer who also holds a master's degree in environmental management and international business, 3 decades of experience in waste management, waste to energy conversion, water and wastewater treatment, bioremediation, and air pollution control. In this divisions indigenously produce important technologies that have been effectively applied in several projects. Welcome. So last but not the least, Mr. Karthik Prabhakar, Head of Operation, Inclusive Energy Limited. He's a Director of Inclusive Energy India, engineer with a master degree in strategic management from Kochikode, right? Yeah, Kochikode. So he has devoted his life to developing technological solutions for traditional agricultural challenge and sustainable living. So I've got more in fact here. So as a fervent believer in emerging technologies, he has more than 12 years of cross-functional expertise in diverse industries ranging from greenfield IoT to biofloc shrimp culture. Welcome. So that was a brief introduction, but the structure we would like to follow that, I think you are going to talk about, few of the solution through the presentation as well. So time is a constraint, so we would request that please be as concise as possible. My request would be that please define the problem statement, what exactly you are catering, so that we can talk about the solution statement very concretely as well. And any question, is very, very important that the energy also comes from the audience side. So there is nothing like audience or, someone giving a speech over here. I think always we say that IBA is a family, it's IBA family. So please feel free. Let's have a very open, heart-to-heart discussion. We can take our heart out. Doesn't matter, we are here to take something with us from the solution perspective. So with this, I would like to open the floor. Maybe Mr. Kumar, you are already working in decentralized solution, waste management solution. India is a very diverse country. I think everywhere you can't say that I have got utopia, I have got some universal solution that fits very well for every problem. It can't be. Life is like that, right? So it will be quite good if you can just share your experience, what you're doing, and the problem statement, which is very important. Over to you.
Thank you, Gauravji. I'm very happy to be in this edition of REI. I have seen the bioenergy pavilion growing every year, and this has been the fattest year for us. We are growing very healthy, right? So congratulations for all of us. We are making it grow. I concentrate more on municipal solid waste because that is a waste which is there, available, needs to be addressed. So I have been concentrating on that, and I have to talk about a very good regulation which happened with the government. It's called the waste bulk generator rule. See, any city, metro city, tier 1 or tier 2 cities, the waste bulk generators produce 60% of the waste. Only the 40% is produced by the normal individual houses, residences. So who are these waste bulk generators? If their 60% waste is processed in situ, then there is an amazing transformation which can happen. 60% not going to the landfill. So that is a very beautiful rule which is drafted by the government, but not every city is enforcing it well. But if they enforce it in every city for that matter, every city on the planet for that matter, it can be a universal regulation to most cities where I just want to talk about some waste bulk generators. The large condominiums, apartments, hotels, restaurants, shopping malls, software tech parks, all these are waste bulk generators. And if they can process in situ, they can do a composting plant, or ideally they should go for a biomethanation plant. If they can do a biomethanation plant, they can give the gas to their canteen, or if they have quite a bit of waste, they can even convert it into electricity and run their common area lighting. This rule actually has helped a company like me in Bangalore because it is quite a big enforcement there. And if the builder or those companies, the large waste bulk generator, if they're not processing in situ, they don't get occupational certificate. So there is like a carrot and stick policy. Do a stick, don't renew his license if he is not adhering to these government regulations. Give him a carrot also, give some property tax discount if those people are doing it. So if 60% can be managed with this government regulation, even the municipalities, with the unbridled growth of cities, even the municipalities are in strain. Let us respect that also. So I feel this rule has to be applied in every city, and that's going to help everyone. So I mean, as municipal solid waste is concerned, even the segregation will not become a challenge because the waste is 500 kg, 1 ton, 5 ton, 10 ton. They can be segregated very well. 99% segregation is possible with this. So I'm a big believer of this waste bulk generator rule, and I hope every city enforces it, and people like us speak to the respective municipal commissioners, the pollution control board people to enforce this rule. That is my take on the urban waste where biogas can play a major role. Thank you.
Thank you. I mean, it makes sense. We talk about circular economy, right? But we need to really adhere to some of the basic things. Otherwise, we'll keep generating all the landfill. Once I went to one of the school and I was just trying to address children from class 3, in fact. Okay, we'll talk about it then, about the presentation then. Just feel free, if you want to give the presentation, you can give the presentation as well, it's up to you. So what I was saying that, and I just showed them the picture of the landfill and I asked them, what is this? And they discussed among themselves and they came out with a word called trash mountain, which is true in fact. What are we doing? What are we giving to the next generation? I mean, anything you think about, any kind of ill effect, whether it is groundwater pollution, surface water pollution, all the vultures you see, the smell issue, health and hygiene issue. I don't know. I mean, this is what we humans are doing. If you go to jungle where animals are living, it's so soothing, so beautiful, you know. I don't know what we are doing. So we need to really rethink. We really need to revisit the way we think, the way we act. This decentralized solution is one of the very important things, especially you talk about tier 1 and perhaps tier 2. But even in tier 1, the enforcement is an issue. And that's the real problem. I mean, slowly it's coming up. And government also wants to really give a proper push to it, which is a good sign. But I think a lot has to be done. Otherwise, you know, every day this mountain height, thrash mountain height is simply increasing, increasing, and increasing. Not good for anyone, in fact, including us as well, because on one hand, we are just in this AC room. On other hand, when we go out, you never know what kind of disease you'll get. You know, it's all open, right? Anyways, so maybe I can just come to, Dr. Daryapurkar, to you, because this all have to modeled out. When you talk about bio-CNG plant, especially at the larger scale as well, you need to think about different business model. You already have done so many projects, you have got a lot of experience. If you can just put some light on it, especially based on your experience in this field, how do you think the business models can be lucrative? Of course, economically, financially, it has to be lucrative, but at the same time, it has to be feasible as well on ground, so that it's not just the paper which says, okay, everything is feasible. So could you please share some of your experience?
Thank you, Gaurav. Namaskar to the audience and fellow panelists. I remember my olden days, 36 years back, when I started my career, and biogas was just a beginning in India in '86. We put up our first anaerobic plant, biogas generating plant, in Tanaku, in Andhra Pradesh. And when we used to show that plant to people in the north, they would say, "Oh, ठीक है, south में चलता है, north में चलेगा क्या? इसकी क्या guarantee है?" So that kind of apprehension was there in biogas industry, of course, for wastewater in those days. Same is the scene even now. 4.5 years, and we have only 38 plants in operation, CBG plant. So naturally, the anxiety about its success, the risk which developer would take is still an issue. Now, at our end, when we do end-to-end projects, we do it in different models. We do it, if client is ready, we do it on design, engineering, supervision, and critical equipments. If the client has execution capabilities, that is one, to bring down the capex, our overheads would be saved. Second is that with or without civil work, we take entire EPC part as a turnkey contract. But still, in both the models, the 100% risk of success is with the client. We go next step where we invest or co-invest in the projects to develop, where we do the job on our investment basis, either fully or partially. We suggest to have a JV or SPV with the client, with the press mud supplier, or with the substrate aggregator. And this JV can run for 1 or 2 years, and then depending on the client's requirement, they can continue or they can exit. And this, we can continue, we can exit. But then technology, engineering, operation, execution, all three aspects we can take care of. So in this particular model, what we have seen that the project developers' comfort is much higher, and probably win-win combination is possible in this model. And this is what we wish to offer to our client, and I'm sure this can mitigate the risk partially, if not fully, with the developers. And that is what the developer would look for.
Sure. I mean, makes sense. See, ultimately, when project promoter is putting a plant, he wants to also ensure that plant runs as well. And it's a pity many times because of many issues, technical issues for sure. Then we need professionals who can really ensure that they are a part of the project all the time, not apart from it once the project is up and running. Because, it's almost like, how do you say, keeping a baby. You have to really feed well. You have to really take care of it. You have to really ensure that it's getting what it should, as simple as it. But nevertheless, different kind of business models can be thought, as you rightly said. One of the things we keep hearing in India, especially when you make waste-based large-scale biogas plant, is the waste availability. Waste is available, that's not a problem. We are sitting in Greater Noida, I don't know, 100 of tons of waste, organic waste is available, it's going to landfill. The million-dollar question is whether or not it's available to us, that too, at the right time, for the right price, in the right quantity, right quality, and, and so on. So supply chain plays a big issue. And let's say if everything goes fine, then we have the raw material. The next question normally people ask many times, that it should not happen that the same raw material is competing even in the agricultural sector for different other things. I mean, biogas is one of the solution, right? It's not the solution. It can never be, any solution cannot be the solution. But because biogas has got the multidimensional benefit, we keep talking about it, we really believe in it. But maybe with this, I can come to you, Mr. Krishan, how do you see this feedstock competing for different solution, let's say even from pellet perspective or ethanol perspective, you have used cooking oil, you can talk about biodiesel or something like this. Can you put some light on it?
Sure. So from what we've seen is that, although agri-residues tend to compete largely in all the biofuels, what we've seen is whether it be solid biofuels, most of it is the dry agri-residue and waste that need to go. Bio-CNG that way can depend on wet organic wastes as well. So wet organic wastes can move towards Bio-CNG. Used cooking oil and edible oil refinery wastes move towards the biodiesel value chain. The sugar industry wastes do go towards bioethanol. Currently with the cellulosic bioethanol policy, you will see some amount of the woody biomass also competing in that space. So although largely if we see from a broad classification, they do compete, agri-residues do compete among all biofuels, but within them there's a clear demarcation as to which type of waste is going towards which type of biofuel manufacturing. Our objective is to ensure that that's optimized, that each type of waste finds its biofuel manufacturer, whether it be dry, so through biofuel.com, it reaches the briquettes manufacturers or the pellet manufacturers. Similarly, wet organic wastes find their way towards Bio-CNG manufacturers, and similarly, edible oil refinery wastes find their way towards biodiesel manufacturers. So on a broad scale, that is competing, but when you go more and more deep into it, the idea is to ensure that all these wastes find an optimal buyer in some type of biofuel or the other.
Yeah, but don't you see a lot of practical challenges? I mean, theoretically, I understand what you mean. Technically, you might have set up all this thing. But when you really go at the low level, at high level, everything sounds quite fancy, and it has to be like this. But when you go at the low level, really in detailing, what kind of social challenges, what kind of other challenges you see, or do you think that other stakeholders, they play a role over here? Because ultimately, all these nodes need to be connected, dots need to be connected.
Yeah, I think still supply chain is a challenge. In fact, that was one of the reasons why we set up Biofuel. I, as a biodiesel manufacturer myself, found it extremely challenging to get these raw materials and manufacture. The point was, so what I was coming to it, well, you're right that there's a lot of challenges on the ground level. Still working? Yeah, so there's a lot of challenges on the ground level. There's still, in fact, of the 400 million tons of waste that we produce as a country among organic wastes, less than 100 million tons actually comes into the biofuel value chain. The rest of it is either burnt or dumped. So still there's this 300 plus million tons of waste that can actually find its way to the biofuel segment. So, and that happens with an optimum or with a supply chain system, aggregation system that's organized. Even the 100 million tons that's there, Gaurav, you must be knowing that a lot of that is syndicated, a lot of that is controlled within these regions by a very few people. unorganized players, which is I think very common till agri-tech came into space. That was common among agriculture also in India. So I think we need to cut that clutter, make it more organized, and ensure that the supply chain is established in such a way that the right kind of waste finds the right kind of biofuel manufacturer.
Sure. I mean, as I told you at the beginning, we talk about technical bucket, financial, and social. India is a relationship-driven country, and even for the waste to get it, you need to really develop some good social model. One of the model earlier, Dr. Shukla, when he was in MNRE, there was a project in Gujarat. I was also associated with it. Gobar Bank, so dung bank kind of thing. That was for the rural area, very rural area. And it worked very well because it was based on the symbiotic relationship. There is, the word in Hindi for symbiotic is sahajivta. Sah means together, jivta means you are living, yeah. So you are living together. So the supplier, he is also getting a piece out of the whole cake and pie, in fact, and other way around as well. So I think again, socially, you need to model it out in order to really make it happen on the ground, and it has to be tried out. There is no abracadabra kind of thing. But maybe I can come to Mr. Anand. I think you want to give a presentation as well. So if you can address this, especially, I think you are also working in a decentralized manner, right? So if you can just share the problems you are facing or normally this sector is facing and how you are trying to bridge this gap, that would be quite good. Yeah, of course, please feel free. My only request would be that if you can just wind up in 5 to 6 minutes, that would be great.
Hello, check. Yeah, good afternoon. So CanCureBird, it's a company where we do decentralized and centralized systems as well. So this is with a German collaboration. We brought decentralized plants, and also we use their experience to build plants in India, indigenize the whole thing, and also export from India to the other countries as well. So that's a brief, and here what you see is like a container-shaped biogas plants. These are decentralized type of systems. Now, when we talk about biogas, it should reach every nook and corner. We have been talking only about the centralized biogas systems. Then we moved into decentralized systems. Now we are talking about micro-decentralized systems. It's like mobile phone, so how the reach of mobile phone has increased now, During those days when we had pagers, the revolution changed into mobile phone, and now everyone holds a mobile. So biogas also should reach each and every nook and corner. Then only it can become most popular. So that's where we come in with the micro-decentralized systems also, smaller systems, which are more challenging than a large-scale plant. When you put a small-scale plant, there are other technical issues which needs to be addressed. So that's where our expertise comes into this. So we built up plants right from 100 kilograms onwards up to these modular systems up to 3 tons per day. Then it becomes modular. You can just keep on adding these modules up to 3 or 4 tons and integrate it. And any biogas plant, the main challenge, as you pointed out, the technical challenges is that you should have a better consistency. Most of the plants, they don't deliver the consistency. Like you have the gas production, but if you take annually, you see the consistent pattern, at least on the guaranteed, it should be 80 to 90%. That sort of consistency is possible by incorporating certain technological advancements, like what we have is mixing systems. There are many mixing systems which are, again, consumes power and circulation systems, different types of systems. So we use one of the important mixing system called power of nature mixing, where our digesters work on the pressure differentials between two chambers. So it will ensure that the mixing is total throughout the digester. This is one of the features and the challenges. And another important thing is how to make, we should not talk only about the biogas. It should be application driven. You have to integrate with an application. Then people will come forward and use that. And we have to give it as a package. Okay, this can be customized, not only produce biogas, because the moment we talk about decentralized biogas, we talk about only connecting to a gas engine or using as a cooking gas. There are beyond that point, there are certain things which can be incorporated, so which needs to be explored. So that's where we have, like, if you take a biogas engine, there will be heat losses, which can be utilized for space cooling as well as space heating. So in the tropical climate, we need a lot of cooling. So with the waste heat available, we can even run a small vapor adsorption chillers for smaller capacity or larger vapor absorption chillers as well. And the other recoverables are there, like the gas you can produce hot water. So many other applications can be integrated. Heating, cooling, power generation. That's why we call it as CCHP, combined cooling, heating, and power. So focus should be like this, and you should bring it under a decentralized systems. Nutrients, one of the vital things, so has to be recovered and put back into the soil. So that will eliminate the pollution, and also this will create a revenue stream. So we are enriching the nutrient through a nutrient recovery process as well. Currently, this is a challenge where to dispose this nutrient. This is another protein-rich food which can be again used for slightly decentralized, large-scale decentralized plant, where you can produce even a protein-rich product called black soldier fly larvae out of the digestate. This can go as a poultry feed or for aquaculture, which is having a huge market. These are all unexplored potential which can be utilized and can be explored. Particularly a dairy farm, the applications. This is one of the important applications. What you see is a dairy farm where the cow slurry comes in and substrate is available. We convert into gas and power the gas engine, which can take care of the power requirements in the farm, and the space cooling as well. Our chillers can be run with the waste heat. Organic manure, again, can be utilized. So all recoveries are possible. Industrial canteens, not only for, if you take a hotel industry, they use a garbage storage area where they use cooling, so there we can go with the DC chillers powered by biogas engines apart from cooking and hot water production. We have also come out with the containerized biogas plants for smaller capacities, because many of them want to understand how this substrate works, whether this substrate will produce the required amount of gas. We are not sure about before going for Satat scheme, 2,500 kgs or 5,000 kgs of bio-CNG. There exactly these type of models will fit in. So we have come out with a small models right from 3 ton onwards, per day onwards. Just a testing protocol can be carried out using these type of systems. You can run these plants for about 6 months, estimate the outputs, then scale up to the next level for the main plant. So we also have this decentralized options. And this is another concept, particularly which is more suitable for government, municipal corporations, where they need not have to bring all the waste to one centralized area, which is the biggest challenge. They can have decentralized systems at several watts, and you can put a bio-CNG, small bio-CNG systems there, and need not have to compress there. We can have the mobile refueling station, which can go and pick up the gas, and compress it, come to a common location, and dispense it. So you can set up at several locations. This will eliminate the logistics cost and other thing, and it makes it very, very simple. Project realization time is very fast. EV charging station, everywhere now we use solar for, but solar is again limited, only for 4 to 5 hours you get. But with the bioenergy, energy is available round the clock, 24/7. So the same EV charging can be done using the bioenergy as well. So these are the hybrid systems. One step ahead now, a lot of work is happening on biohydrogen. It's called hybrid systems, where you produce biogas as well as biohydrogen. So this is what is catching up now, and we are proud to announce that we are executing one project in Europe for biohydrogen as well, which we call it as a dark fermentation process. So this shows the future potential of biogas, not only restricting only to the biogas, in the same pathway, how you can get maximum recovery as possible. So when you put the maximum recovery into the picture, the return on investment also will be attractive, and many will come for implementing these decentralized systems. 100 kg systems for universities, colleges. Just to have knowledge, we need operators, for operating this plant. So a sort of skill development can also be done with these type of small systems. We have a training academy to train people on the biogas and train the operators so that they become employable. So biogas is truly sustainable. That's my last slide. Approximately about 1.5 tons of carbon footprint can be offset with 1 ton of food processing. And worldwide, about 20% of greenhouse gas can be eliminated. And if you see the sustainable development goals, out of 17, 9 could be met by going with the system, this biogas system. And I always used to tell my client, everyone asks, what is your ROI? How fast I can get an ROI? By adopting all these things, definitely you can get a better ROI. But put ROI at the second stage. The first stage should be ROE. We call it as return on environment. What is that we are contributing to the environment? If you are sustainably inclined, I think business will boom automatically. Thanks for giving this opportunity. Thank you very much.
Thank you. Thanks a lot. In fact, this question keeps coming ROI. Especially for this kind of small-scale plant, I don't think we should even talk about ROI. I mean, we are sitting here. What's the ROI of this chair, this sofa, this table, this light? We need it, in fact, yeah? So if you're producing waste, you need to really treat the waste, as simple as it. It's our responsibility, directly, indirectly, whatever you call it. Yeah? But in fact, this is a technical session. So, Mr. Anand, I have got a couple of questions for you before we proceed further, and technical only. Okay, so I'm not going to ask you for anything financial. It's a hardcore technical session. So, when you talk about this small-scale biogas plant, so producing biogas is one thing, but you went for the tri-generation as well, which sounds interesting, especially from the technology perspective. So when you talk about electricity, my question is that at large-scale biogas plant, I don't know, we can get 42.2% electrical efficiency. Even we can go higher. Overall, 80% efficiency when you also take heat into account. So can you just talk about a little bit about efficiency, and also when you convert it into let's say through VAM, in any cooling system, through any cooling system. So let's say 1 TR, or if you have to produce that much of heat, that much of cooling, how much heat do you need? So can you just throw some rough figures on it?
Yeah, absolutely. Basically, to address your first question, is the energy efficiency is not only pertaining only to the gas electrical efficiency. I think we have to look into the overall efficiency. Because smaller the gas engines, you won't get 40% or 42%. So you get a very low efficiency, maybe 30% or less than that. So the balance of 70% is the thermal energy, out of which 10% goes, we cannot capture, but rest of the percentage is available. It's about close to about 60% is available. So we can make use of that to produce hot water, and thereby use it for some of the applications, like hotel industry can use it for hot water, so they can cut down on their electrical, this one. And many other applications are there, as I told you, cooling. So typically, if you see the TR, so if you put let us say you have a 15 kilowatt gas engine, I can say it's about 7.5 kilowatt of thermal energy which will be available. You can produce about 2 TR. You can run a 2 TR space cooling is possible with that.
Just out of curiosity, and then we'll move to the next speaker. This is the CHP you showed, right? So have you also experimented with micro turbine or something like this?
Micro turbine we have not done, because micro turbine now this is not being produced in India, so the cost economics doesn't work. though it is good and we say that hydrogen sulfide removal is not required, the economies of scale are not very attractive, so currently.
Sure, makes sense. Yeah. Maybe with this, we can move to the next speaker, because anything we do, I mean, even in the largest biogas plant, we need to quantify everything. We need process control, we need data collection system, we need data acquisition, we need data analytics, interpretation, everything we need. I mean, Reliance once said that data is a new crude, and I think they meant it. They really, really meant it. So we need to generate the quality data in the plant as well. We need to analyze, we need to control everything. If you talk about IoT, if you talk about any, I don't know, you can talk about DCS as well if needed, I don't know, SCADA or any XYZ thing, but nevertheless, it's all about process control. Maybe with this, I would like to invite our next speaker, Mr. Prabhakar, to talk about their work in this field.
Good afternoon, everyone. My name is Karthik Prabhakar. I'm representing Inclusive Energy as the head of operations here today. So I've been invited to talk about the need for process control and analysis in the biogas industry. So let me introduce the company first. So Inclusive Energy is a smart metering company working in both off-grid solar as well as the biogas sector. And we bring value proposition to our customers in three folds. So one is enabling them to increase the market size through flexible financing models and by reducing their repair and maintenance costs through remote diagnosis, monitoring, and troubleshooting solutions. And thirdly, and most importantly, we also support them with affordable carbon reporting and monitoring. So we are present through our customers in over 20 countries where our products are being piloted and used, and we have sold more than 3,000 products so far, and large-scale projects are in operations across the world, especially in the global south. So the journey has been good so far. So coming to the topic, biogas. So before jumping into the problems and the solutions, I would like to go through a few of the increasing applications and use cases in India for biogas. So I'm not going to cover the large, sophisticated biogas plants like the schemes, like Satat and all that, because we have spoken a lot about that. But what we have seen in India through Inclusive Energy is what I'm going to show. So what is biogas giving? So it acts as an affordable replacement to traditional energy resources. It leads to localized energy generation. It reduces import of energy and also acts as an environment-friendly fuel. And it supports sustainable management of organic matter that's produced from agriculture. And the other microeconomic benefits that goes to the users includes energy, fertilizer substitution, additional revenue stream, and also it increases the agricultural produce. Yeah, so these are some of the applications that we have worked for, and that particular picture is from Mr. Dev's factory itself, I mean, Dev's site itself, so that's becoming popular these days. So first of all, there's domestic usage, so it can be a rural household or a dairy farmer's household, caters to the farmer's cooking needs, lighting and cooling, etc. And it also generates additional revenue from the byproduct, which is slurry, and saves time on collecting wood, money on LPG, and also reduces the health hazards. Bio-CNG and CBG plants, which means upgradation of raw biogas, bottled or piped to commercial kitchens, are also used as a transport fuel. Power generation projects, again, like Mr. Dev was mentioning, the biogas from poultries and dairies can be fed into electric engines, and the power generated can be fed back to the same utilities. Institutional biogas, in general, it's a large central digester, which is normally operated by a community or by an organization. So the gas is produced in bulk, and it is transported in a truck or in a bottle or through pipelines to kitchens, etc. And the user gets billed on usage base or as a prepaid billing charge. Finally, there are R&D projects. So there are organizations and institutions working on different types of feedstock. For example, there is a company in Delhi trying to generate biogas through leather waste, and the future lies in the availability of efficient and abundant feedstock. We all know that. This slide to mention about the women empowerment that's brought to the table through biogas. All right, so how is process control and analysis going to forge the way for the future in biogas industry? So let's start from the problems that we have seen in the past and the learnings. So lakhs of digesters and hundreds of programs have been abandoned or compromised due to the lack of monitoring metrics, assets, and also milestones that really drive the efficiency of any large project. The key challenges in the industry that we see, and I think largely this audience would also agree, is the role of the user or the technician who's handling a digester. So he has to feed the digester optimally and regularly. And moreover, the gas and the manual management comes into the picture. So the gas produced has to be used regularly, and if it is not being used, it's going to enter the atmosphere, which is not what we want. And the byproduct, the slurry, there has to be a process in place for it to be collected, for it to be processed, and then used as a useful mineral or nutrient in the farm. So technical challenges, so there is product quality. A substandard product is always going to break the trust of the user, and lack of digitization means it's always difficult to assess the efficiency or the effectiveness of the digester and its performance. Finally, and most importantly, there is social and environmental challenges. The inability to sustain the project or the digester due to unavailable feedstock, or the inability to pay due to lack of payment plans with a proper process and control in place. And finally, also the acceptance of biogas in the user's household or in the society, which is actually a mental block, and it needs functional systems to be in place, and there has to be proven solutions, and also incentivization that will bring the trust and awareness in the users. So to quickly summarize the problem, so we have the end users having difficulty with upfront costs, system breakdowns, and the businesses and program owners having difficulties because of lack of oversight and data, and inflexible offerings means the solutions that come up are not compatible with every kind of digester. And with technology, we have no remote monitoring solution, lack of digitization, and the conventional methods of monitoring the project. So yeah, having said that, now I would like to introduce something which is, so at the bottom what you see is a basic digester system. And I would say that, our proposal is to have a smart meter that is coupled with IoT and sensing capabilities, which always keeps monitoring the system in real time and pushes the data to the backend, that is to a server, where the data could be analyzed, processed, broken down, and then it can be fed back as meaningful insights and useful alerts. And you can see that on your laptop or from your mobiles. So what does digitization bring? It gives you data, which brings insights and metrics on the digesters, and it also allows the company to design and operate their systems efficiently. Analytic tools, it provides value in 3 different ways: automated fault diagnosis, it helps in harnessing carbon revenue, and it also enables companies to provide energy as a service. And lastly, needless to say, it enables a digital approach to the carbon MRV market. So here is what we do at Inclusive Energy, and we also look forward for this industry to adapt to, is use a web application to monitor all the digesters that's in the field in one place, and it is going to be valuable to the project owner or the implementer, for example, the dairy cooperatives or the NDDBs and the likes. And oversight application to give the access to the project sponsors, example, MNRE or even Government of India in this case. So that's going to give them a means to keep track of what's going on in the project, how far it has gone, and how well it is going. And yeah, the user has to be, I mean, you cannot avoid the user or neglect the user. He has to have his own value. So through a mobile app, we think the end users get insights into their digester's performance, their usage, their savings, and also their billing status. And it also empowers them to identify malfunctions in their own digesters, for example, a leak or a pipe burst, and they can report it to a technician via mobile phone or a WhatsApp. So that's what digitization brings to. Yeah, the success of any large-scale project, let's say the such a scheme.
Kindly wrap
It's
in
done.
1 minute or something. Yeah?
Last one. So a data-heavy dashboard is what I propose to actually measure the metrics and milestones of a project, which determines the success of the project also. So you get to know how many digesters or how many installations have happened, how many are functioning and non-functioning, how many has a problem, and what's the gas produced and carbon that's offset from the environment, etc. So this is a digester page which gives you the overview of the health of your digester and also the performance and the usage or usage pattern. This is a customer overview page where you can access all your customers from this digester, customers page. And finally, as we go forward, we think there is tremendous scope and a huge future to digitize the whole value chain for biogas, right from handling the feedstock to gas to bioslurry management, operating a bio-CNG plant, and even mobile money integration for payments. And lastly, we think that using a smart metering solution to do the carbon measurement, reporting, and verification is going to actually increase the quality of your credits if at all carbon credits picks up in India, and it's going to also increase the revenue from that. So thank you for your time, and I hope I was able to shed some light on this.
Thank you. Thanks a lot. That was quite an insightful. Of course, you have to measure, then only you can come to any conclusion. I think Mr. Anand has to leave. He has to catch a flight. So, Mr. Anand, thanks a lot for being with us. It was a pleasure. And just a second, could you please hand over?
Thank you so much, sir, for being with us. But before you leave, sir, we have a token of love and appreciation for you. May I request the moderator of the session to kindly present one. Over to you, sir. Over to you, sir. Microphone.
Yeah, we'll continue the panel discussion. So once again, IoT or data measuring devices are very important. One of the big challenges we see, Dr. Shukla asked me long ago, can we do something for the small scale biogas digester as well? So of course, when you talk about carbon credit, when you talk about all other things where you have to bundle it out, I don't know how the cost economics or cost effectiveness will work out, but definitely you need sensors, and I personally feel that IoT is just a fancy name for sensors, in fact, yeah. So not to be confused with anything else, just wanted to make the thing simple. But maybe this brings me to the next point. Mr. Kumar, with you also I had a lot of discussion, and you once showed me as well that in one of your plant, I mean, there might be many, but I know one which you installed in Rashtrapati Bhavan, President House, where you are taking care as far as the organic waste management is concerned from the decentralized perspective. Maybe you can share your experience along with this, especially what do you feel about the data acquisition? How do you really see the other gaps in the market, and how you are bridging it? Over to you.
Yeah, the Rashtrapati Bhavan plant was a landmark project for us. This is, in fact, it's the world's largest acreage of land for any president. It's bigger than the White House. So there's a lot of garden waste, then there is cows there, and many support staff that waste. And also they have horses in their cavalry. They've got 99 horses in the cavalry. All this waste, the dung, all that gets mixed, and we produce almost 60 to 70 kgs of gas, and we are powering 2 of the canteens. And the fertilizer which comes with that is also utilized for a huge landscape at Rashtrapati Bhavan. So this is, of course, also we have put in an IoT system there. We get to know what is the pH. We keep on monitoring the pH there. We also keep on monitoring the temperature, because Delhi's temperature goes down. So we have a thermostat. We control the temperature, and also we have the temperature controls, the pH value, the amount of waste that was put in, and the amount of gas produced. All that is on a dashboard. So although I'm based out of Bangalore, I can see what is happening at Rashtrapati Bhavan. And imagine I'm doing more than 630 plants and counting. And only if I had IoT on each of them, I would be knowing how much carbon footprint I am reducing, and how many tons of waste being reduced, and how much of gas we are producing. All that IoT makes a big difference on that. So that is my only thing is IoT costs some money, and customers should start investing on IoT. But in case of decentralized plants, the plant itself might cost you, say, about 12 to 15 lakhs, and IoT should not be very expensive. So in that way, the IoT pricing should come down, and then there is a huge opportunity where through a central command center, we can check how much of waste is being produced and how much of gas, all that. The health of the digester can be managed through IoT. And it has been a great experience for me at Rashtrapati Bhavan, having an IoT setup there.
Kumarji, we are running out of the time, so maybe I take the last question. Is for you, Dr. Daryapurkar. We talked a lot about different kind of waste, but lignocellulosic waste is one of the things which is still challenging. Can you share your views as far as the lignocellulosic wastes are concerned?
Sure. In this industry, since last 2-3 years, the first wave came of press mud. Everybody was talking about press mud. Later on, most of the discussion was around rice straw or paddy straw. And now, a lot of interest is shown in Napier grass, which is lignocellulosic material. Now, Napier grass is one substrate which is available around the year, perennial crop, and it can be within the control of the developer, unlike press mud or any industrial byproduct. So, Napier grass, if cultivated properly, with a good yield of about 150 to 200 tons per acre per year, with a cultivation cost landed at site less than 1,000 rupees a ton, can be a good alternative, a good source of biogas or CBG generation with a recovery of about biogas yield of about 5 to 6%. The main challenges currently is the lack of operational data over a period of time. That is one challenge which industry is facing. The solution or the key items, debottlenecking, what is required is size reduction. That is one area where research is going on, and we are also working on that. And pre-treatment. Incidentally, a lot of work is being done on second generation 2G ethanol for using lignocellulosic material for ethanol production. So all those pre-treatment technologies would be applicable here. And with that knowledge available, now some technologies are also available, and we are pursuing them, where lignin can be removed or recovered, and lignocellulosic material can be separated before feeding it to the digester. So these are a few things which, taken or handled properly, will give a lot of traction for lignocellulosic material for biogas production.
Yeah. Sure, thank you. Of course, pre-treatment is something you need to really pay extra attention as far as the lignocellulosic substrates are concerned. Well, I think it's time to open the floor and take few questions. Any question? I hope you all are still awake. Are you awake? Sure, at the end? Awake? Okay, good to hear. Yes, please. Can we have the mic, please? Over here, at the front.
I have a question about, we talked a lot about IoT monitoring and things like that. Has anyone or everyone experienced here security issues with accessing the sensors and all that remote, particularly sensors? I think accessing the application, there is enough security, dual factor authentication, things like that. But when you talk about controlling the sensors remotely in a larger deployment, what are the experiences that the panel has with that?
Well, I can share my experience. I used to work for Shell earlier in Germany, and this was my bread and butter, advanced process control. I think remotely they never allowed to write something. It was only read-only thing. And as you rightly said, the safety issue, or maybe you are sitting here and you're trying to control your refinery, and by mistake you enter 0 instead of 100. This might be disastrous. So it was never allowed. I think that for the right reason. Technically you can do that, but I don't think it's the right thing. And also when you talk about vulnerability, or you talk about any safety, security, all kind of issues, because then your plant is not aloof. It's not a standalone plant. It's, anyone can do anything if he's smart enough. From IT perspective. So I would personally say that I would not be a big fan of writing it. Just read only is fine. You're getting the data, you're just unidirectional, as far as handshaking, or you talk about this two-way authentication, etc., I think that makes sense. One of the interesting, maybe just one of the issue I saw, and they solved it out with the help of IoT. I was talking with one of the vendor, and he says that my equipment is very costly, and I get my 10% after I deliver it, after I commission it, and all this thing. And what I do, I simply lock it with the help of IoT. If I don't get my money, they are not able to run it. I don't know, but I'm just telling you that you have all kind of handles. You need to tweak it as far as in the right manner, in fact. The intention should be pure. I'm not saying that it should be other way around, but I think it's more about defining the problem again over here, what exactly you're trying to sort out. Do you want to know your H2S percentage before it enters your, let's say, upgradation system or something like this? So, for the large scale biogas plant, I understand. For the smaller scale, I think it's more about, whether or not you can afford it, or the project can afford it. Please, any question? Well, I'm not passing this question to him because, he's a part of your team. So, any question? Anyone? Someone raised a hand, right, at the back? No? Well, if there is no question, there can be only two scenarios, right? Whether either you understood everything or you didn't understand anything. So I don't know which one to really take. So normally, it's a chance, and as I told you that, don't worry, you can ask any question where you feel that you are facing difficulty, and we'll be more than happy to discuss that. Many times, no one can guarantee that there is a solution, but any other thing you feel from the technical perspective, it's a technical session right now, so we can take those questions as well. Okay, then we are dot on time. If there is no question, we can wrap it up. Thank you. Thanks a lot. Over to you.
Thank you so much, moderator of the session, Mr. Gaurav Kedia, for wonderfully conducting and concluding the session. Ladies and gentlemen, this is the time where we make it a little more appreciating for all our panelists. Thank you. With a small token of love, appreciation, and memory, we present a memento to each one of our panelists, and I request the moderator of the session to kindly present the memento to each one of our panelists. To Dr. Ramesh Daryapurkar, to Mr. Kishan Karunakaran, to Mr. S.R. Kumar, And we also thank Mr. Karthik Prabhakar. May I now invite Dr. Shukla onto the stage to kindly present a memento to the moderator of the session. Thank you so much, Gaurav sir, for wonderfully conducting and concluding the session. Thank you, Dr. Shukla, for joining us onto the stage and presenting a memento to the moderator of the session. Ladies and gentlemen, a huge round of applause as we together conclude the session.